Okay, now rather than me diving into this, and actually, Tom, you and Mike both addressed some of my protocol questions. Let me jump forward, and we'll go to discussion topics number 2. And some of these came from Peter Reynolds, some of them came from some of my ARC counterparts. So much of the emphasis and focus, at least from what I've heard around OIC, is about smart cities, smart homes. Can this be leveraged across all the process industries?
So, I thought about this a lot, and I think to start with, we should ask ourselves the question, what kinds of technologies are likely to be in smart homes that would naturally migrate into a plant, right? So, the most obvious one that I thought of was light bulbs, right? Now I know there is such a thing as industrial lighting, right? Huge things that hang from the ceiling.
True.
But there are lots of regular light bulbs in plants, and it would be kind of a shame if just because it was going into the supervisor's office in a factory, it had to be a light bulb that cost 6 times as much because it was labeled industrial. Right? It'd be nice to be able to do management of lighting in a building using off-the-shelf, consumer-grade stuff. So that's the first thing that came to mind. I think it's safe to say that it will be a long time before we're anywhere near something that's really big and rotating really fast.
That I understand. Now, do you, and anybody else want to address do you see barriers to adoption, either of OPC or of OIC?
Sorry, Joe, can I just answer?
Sure.
Try this is my view. So I am the analyst among the panelists. Just a little bit about my background. I am a pure...
I can't hear you very well.
Can you hear me now? Okay. So I'm the analyst here, and I do work for ARC. I have a very heavy process background, so when it gets too discrete, I'm a little bit challenged. So if some of my views come through, I am pure process. My background is downstream refining, so OPC was my friend for the S95 applications for a very long time. But I just want to, I would actually just like to, I'm going to cheat a little bit. I just want to read something here because I think this is sort of important for the whole discussion we're having here about OPC and newer technologies. This is ARC's definition of the industrial Internet of Things. And it's about the transformation of industrial products, operations, value chains, and aftermarket services that's enabled through the expanded use of sensors, digitization, and networks. Okay, so when I think about connectivity for the industrial Internet of Things, I think about the things that spin as a perfect opportunity. And as much as OPC is my friend in the space of advanced process control, DCSs, and PLCs, I think that the opportunity that the industrial Internet of Things brings is not necessarily to disrupt that layer. I think it's the discrete things that are connected to it, like the servitization, the remote monitoring, and the analytics, which includes sensors on pumps that aren't for control. So I would just kind of want to throw that out there because I think that might make for a good discussion.
Dennis, I think you ought to introduce yourself.
Okay. Yeah, my name is Dennis Brando. I'm actually here more or less representing what the users are because I tend to work with end user companies in pharmaceutical, chemical, food, beverage, and all these things. So I was asked to come up here and give a little bit of that viewpoint as to what the end users are starting to see. And what we're seeing here as things move forward, two things. One, we're seeing integration between the automation systems and the environmental systems. So a lot of the work that goes on in smart cities, a lot of the work that goes on in smart homes actually has a lot of impact inside the production environments, particularly in pharmaceutical, particularly in food, where the environment of the operation is actually part of the critical information that you maintain about it. And that's always been a problem. How do you bring those two things together? I'm glad to see OIC here because that's the area they tend to deal with. And the OPC and the OPC UA tends to be pervasive in a lot of places we see. Obviously, we have Profibus and we've got DeviceNet, et cetera. But as soon as people start putting systems in place with lots and lots of different vendors, they're using that, the OPC. I have been involved in helping the OPC Foundation develop some of their data models for complex data, and that, I believe, is what we're going to really start to see as we move forward on the IoT. Because we're not talking about, is it open, is it closed, is it running, is it not running? We're talking about bringing a whole bunch of information from any one of these devices and making it available. We all heard about the analytics, everybody sat in or heard about the analytics, we talked about. This is the stuff that feeds that. You got this massive beast that needs the data. Where's that data going to come from? Because it's not just simple data, it's information and context and complex data. So I think this is what we're starting to see. People are starting to put this in place. The prices have come down, the adoption rates are coming up, the barriers to entry are going down because everybody has Ethernet in their networks now, in their industrial automation systems. It's become very pervasive, especially any system where you're within four walls. Move outside, it's a little bit different.
Okay. We got a comment, Tom, or otherwise we've got a question from the field here.
I want to make a comment a little bit about the smart city and the smart home market. I've got a lot of my vendors that actually have been starting to dabble that, specifically in Germany, and with a lot of the different building automation vendors. For example, OPC UA has a very tight partnership with BACnet, and it's the BACnet group in Europe that actually is looking at putting and basically mapping all these BACnet objects into a UA namespace. And I had the opportunity to talk to the guys from BACnet, and they said, well, the biggest problem we have with the smart homes has to do with everybody said, but it's got to be easy to use, and it has to have a very lower cost barrier to entry. You know, it's one thing to have a smart thermostat, and I can be able to set this from my smart device or my smartphone and operate this thing up and down. It's another thing, do I really want to monitor my energy utilization? Yeah, I probably do, but is it a novelty for a period of time? And I think that's what the BACnet guys saw when they went into the smart home industry. They said it was more of a novelty. It's a play for now until you actually see a return on the investment for actually doing this, right? The smart cities case is different. The government sponsors this thing, they're going to go do it, they're going to have a lot more control over the different components. But on the home market, it's a little bit, you know, it's still kind of a toy. It's still kind of a novelty in a lot of ways until you can really see, is what we talk about all the time, a business value proposition for justifying this.
John Schrader from a question really more for Mike from OIC. I understand that you acquired the assets of UPnP.
Right.
And interestingly enough, our factory relay product uses UPnP for discovery. And of course, we have plugins to support the protocols like OPC and others. I'm just curious what you see happening with UPnP and its potential application in industrial environments. And then also sort of merging it into things like sort of like a home relay rather than sort of factory relay.
Right.
Embrace all of these other protocols as well.
So UPnP stands for Universal Plug and Play, and it's probably one of the oldest smart home standards efforts out there. It started in the mid-90s, and it's probably shipped in 3 billion TV sets or something. I mean, it is absolutely everywhere. What happened was that a lot of the people that were going to the UPnP meetings started branching out from TV sets and things like that to things like home control. Hey, let's use the same device that controls your TV set to control the curtains in your living room or whatever, or the shutters on your skylight. And they started writing standards for IoT. And then it turned out the same people from a lot of the same companies were coming to OIC meetings and proposing the same things. And they say, this is kind of nuts, right? So the groups, they basically, came over, brought all their stuff with them. So the UPnP specs are very much alive and will continue to be maintained by our organization. what it allows us to do is keep one more piece of fragmentation from happening, right? We kind of nipped it in the bud collectively, and it will allow us to get a head start on A/B extensions to what we're doing for things like, monitoring via video and things like that. And from an implementation point of view, we're working on a plugin for UPnP into IoTivity to do the bridging.
So, a long time ago, in the mid-90s, OPC actually was at Microsoft, and we were looking at the UPnP standard for a mechanism, essentially, of discovery. And we had talked about this for a while. We found, it was a wonderful technology, except we needed something a little broader. So I didn't say that the wrong way, I hope not. But essentially, it's about discovery. And that kind of an idea, it's very similar to, you plug something in via USB, right? And it magically can discover all the capabilities of it. So what we've done with OPC UA deliberately, and I didn't do this on my own, it's just a consortium of vendors working together, have actually developed a very significant discovery protocol that allows us essentially to go plug in a PLC or an I/O module, and you can discover all the capabilities of that. And I think that's going to change the way people think about things, because in the past, before we had a lot of this discovery capability, there was so much manual configuration, the level of usability was so significant. I can still remember when you had to program both the HMI and the PLC, you had to put the same information in 3 different times, right? And then you still tried to connect the stuff to make it work and do all the mapping. Now if you think about a lot of the HMIs today, for example, they connect up to the PLC and they get instant access to every single data point and all the metadata behind that, and there's no entry of anything. So that's the difference as we see things. That will make things more intuitive and easier for people to operate, because when you start thinking about, ExxonMobil, for example, a typical system with a DCS is 30,000 I/O points. Think about the manual entry that was required. No wonder you couldn't swap between vendors. You invested so much stuff into that configuration, it was impossible. But now with a lot of this discovery based on technology like, UPnP that existed, actually it started in 1987. It goes way back. We're talking like, 3 decades ago almost, okay?
I had hair then. Go ahead, sir.
We have a lot of use of OPC, DA, HDA, A&E, many uses of that. How do you put over today? And or is this a certain model or framework you can use to make that move over today?
Yeah, I'm going to answer that one for Tom, because he's been speaking so much. Yeah. So the question is, you have a whole lot of the OPC DA, OPC HA, and all the other pieces down there. Is there a future path? Is there a way to connect that? Yeah. One of the OPC UA elements is basically an OPC UA server that collects the data from the lower pieces on the DA model and exposes it in this. So it's a piece of software essentially that you can use in this to expose it. I've also seen people do this with the hardware itself, because there is an OPC UA chip essentially, and it becomes it's a server chip, and it allows you to take the information from your device and expose it out. Yeah, but they built those gateways because he's got 20 million, 40 million of these devices.
He's only 45. Thank you.
No, it's a guy screwing up the audio.
And I may have a wrong understanding of this, but it seems like OPC UA is, it's all over Industry 4.0. It's basically locked in, like, this is the way you're going to do it. At least it's the number one option.
I know, but it's aggravating.
All the stuff you talked about today. How closely are you tied into the industrial internet consortium and one end-to-end more telecom centric? And how does that fit in? Because it seems, there's no one way this is all going to play out, but it seems, just curious in your perspective on that.
Yeah, there's so many standards out there that God doesn't love us. That's why we have so many, not the other way around. Yeah, in terms of the Industry 4.0 and the work that's going on inside there, a lot of that is being driven by some of the international standards such as IEC. Now, an OPC UA has an advantage in there because it is an IEC standard, so it becomes part of that foundational class. The big thing about that, again, was the look at how do you handle complex data in one of these devices, not just simple. I mean, the original OPC was very simple. This is very complex. We built models in there for entire spectrums of gas chromatographs and laser spectrometers and very complex pieces. Now, what's going on is there is currently work to try and bring together many of the other standards that are out there. This is a lot of work, obviously. The whole idea of Industry 4.0 was to say, we've got all these new technologies, let's work on it. We're now in the process of getting these different groups together. So just recently, a reference model was released by Germany that said, okay, here's essentially how all these pieces can fit together. There was a diagram on it in one of the earlier talks, and it uses several different axes, dimensions of how these things are going to look at. What that was laying out was all the different things that have to work together to make it work. It wasn't a model in itself. So there's work going on today, primarily being driven, as far as I know, by the IEC on the industrial Internet of Things. There isn't not yet a whole lot of tie-in to the rest of the industry and the commercial side of it. But I have a feeling that whatever standards end up developing there are going to get rolled into the industrial world right now.
There's a big push from the European market actually to roll a lot of those in. I did, and Dennis, thank you, talked about OPC UA is actually an IEC standard. We're actually part of the reference architecture for the Industry 4.0. And one of the things that the Industry 4.0 guys saw was the fact that OPC had collaborated with so many other information organizations. So, every day somebody comes up and says, well, how come you haven't partnered with me? And it's like, well, I didn't know about you before. But so, for example, all the industrial Ethernet organizations, OPC has a partnership with, and essentially we take the information from those organizations, model the information, put it into what's known as UA namespace, and then this serves as the connector to the enterprise, okay? And this gives them the ability to have, for example, whether it's EtherCAT or Ethernet IP or Profinet, the ability to have OPC, their information now into the cloud, and that's kind of the direction. Recently, we've got a lot of work we've been doing with Microsoft. That's why I let Dennis do more talking than me, But Microsoft has built a connector deliberately. We've actually open sourced that technology that'll be announced, officially here in April. And that allows the ability to have this Microsoft open source technology using the OPC UA architecture, pushing data into Azure. So that's another thing, and it's all Windows 10 based. So collaboration is the key in our organization.
Just one comment on standards, and I think this goes across all the standards. I think there is a realization that cost is going to be extremely important with any IoT Industry 4.0 solution. So I think the expectation is if we have a new business model, we're transforming some operation of our business, some new outcome, I think that there's an expectation that they want to get the data as cost effectively as possible, whether that's by OIC, whether it's using the internet or any other medium to transmit that data with the right level of security, given that some of these outcomes might be different from what we've been used to, with normal discrete control and real-time process control. So I think cost is going to be very important with whatever each group looks at for standards.
Any other questions?
So I want to jump in here with a little bit of a shaggy dog story regarding what IoT actually means in the context of the kinds of things that people are trying to do when they say this is going to be worth billions and billions of dollars. Okay, so if something's going to be worth billions and billions of dollars, the implication is we're talking about millions and millions of devices. So there's an implication that that's affordable, right? And Moore's law says, hey, the hardware is virtually free, right? And this industry jumped on automation when the price threshold, basically when it went from mainframe to mini computers, and then from mini computers to single board computers. There was enough value that you could jump on it and get a lot of benefit out of it. But we're talking in any organization of thousands or something, not millions. So the cost, and that was fine because a Data General Nova mini computer cost $100,000. So we didn't worry about software scaling. Okay, now, if you get the cost of these devices out of the way, then what's the barrier to implementation? I mean, there are a lot. We talk about, you talk about security, talk about where the program's going to come from, and I'll come back to that in a second. But just ask yourself the following test question, right? In your organization, your IT groups, can you name an enterprise-level application that works very, very well with 100,000 users? Can you name, right? And I suspect if we went down the list, you'd say, well, there's Microsoft Exchange, mostly works, for 100,000 organization of 100,000 people. SAP mostly works. The Oracle databases work. And then you say, okay, how many people in the world can build applications like that? Oh, not very many, right? Probably not the ones you work for, right? Not the Intel I came from, right? We couldn't build software like that. We bought it from SAP and Oracle just like everybody else, and Microsoft just like everybody else. Okay. So when people talk to you about the Internet of Things, they say, yeah, but there's this great technology, the cloud, look what Google does, look what Facebook does, and they're handling, millions of transactions a second. They have these incredible data centers, and Amazon is doing all of these amazing things. Okay? And if you ask yourself, well, how are they doing it? They're not doing it with the software technologies that were used to build the original Internet. Okay? It may look the same on the outside. It's got the same Ethernet, except scaled 100 times faster, 1,000 times faster. They're using the same physical servers. Architecture is still the x86 running Linux, but you open the hood and it's a completely different software architecture, completely different. And what they do is they take these big monolithic problems and they slice them into the smallest possible pieces. And they take each of those pieces and they put it into a software container packaged with a little bit of the OS, just the application libraries. That's what a software container is. And then they can run it, thousands of them on VMs, and spin them up just like that, and so on. And the idea is that any one of those software containers is expendable. Right? So you start a transaction, if it doesn't complete, you just kill that container and bring up another one. That software architecture is what the Internet of Things is going to have to use if you're going to be able to scale it to tens of millions of devices. Okay, so we call in OIC, we call this cloud native. All right, we're using this kind of architecture, right? So containers and so on and so forth. Now, a really weird thing is happening. If you look at the software engineers on the application side who use these things, that use these web services, okay, where do they come from? Okay, they don't come from Michigan State University computer science, program like I came from. They don't come from the double E departments. They come from some code camp or whatever, right? Or they come from, gee, I tried to be an English major and that didn't work out, so I'll learn JavaScript, right? So, but here's the thing, right? So ARM, you guys know ARM, the big, CPU architecture company. They had an investor day in September of this year, and they said the Internet of Things will not be built by embedded programmers because there's only about less than 1 million of them in the whole world, and you've got 15 million people that have learned how to do mobile, either in with Android or with JavaScript. They're the ones. So we're going to, and those guys, those young men and women, know how to do things that way. So if you're going to realize your dreams, you're going to have to figure out how to use them. Now, I think one way to do that is to say, okay, there's all this data we want. Okay, we'll give you, we'll have some smart guy that knows how to bridge from, OPC 1 to OPC UA and the PLC data, we'll get it out and all that. We'll give you guys that data. You build the analytics apps. You build the big data apps. You build all that stuff, okay? And there's lots of that data, right? There's way more data going out than you want data going in. And then when it comes to control, we're not letting you anywhere near our stuff. So if you can divide your projects that way, maybe you can get the value out with the engineers you're actually going to be able to find. And I actually think I was really intrigued by the guys you partner with that started out at Caltech or Berkeley, where they said, this is a read-only architecture. I thought, and T-Connect, I thought, okay, that's smart, right? That's really, really smart.
Okay, any other comments or questions from out in the crowd here?
Joe, I just have one comment. I just want to reinforce from a market perspective. And when I think about the Internet of Things a year ago, I don't think the market ever anticipated there would be something called SCADA 2.0 built in the cloud, or industrial Internet of Things platforms, or monolithic suppliers. And I hate to mention a supplier name, but I'm going to mention GE Predix. But the direction for where things are going and where we see the most value is in cloud deployment. So just the way technology is being deployed to support IoT or Industry 4.0 initiatives looks drastically different than the past.
I want to make a comment about, I've had some real exposure to the oil and gas industry recently through an activity that we work on in MDIS, and I learned a lot about how they monitor flow in a pipeline. And they monitor this pipeline basically every 12 feet by having a sensor here. And between every 12 feet, they have to have interconnectivity between the next point down and the previous point before. And I asked some questions, and I got to learn about this. And then they said, you understand, Tom, why what you're doing with OPC UA is so important, because we want to be able to have the ability for these devices to be able to talk together, because we can detect either the flow is less or it's more. And you know what it means if it's less, Tom? Okay? What that means is there's a leak someplace, and this is a bad thing when it's under, 3,000 feet underwater, right? So they start talking about this, and they get this education about, and then we're doing a lot of stuff in the pharmaceutical industry where, you've built products, and you need to know where all that raw material came from and where it's going to, because you need to know about the shelf life of this stuff. So it's about data. But it's more importantly, as I talk to my friends at SAP and Microsoft and Oracle, they're saying, Tom, the days when we had an HMI where all you could see was random numbers and maybe you had some color coding on it at best. Now I want to think about how the gaming industry has changed things. As a matter of fact, one of my HMI vendors said, all the three-dimensional rendering we do is all based on gaming technology we've now done. And I'm like, well, this is still a toy. No, it's not a toy. If you can't be someplace and I need to remotely connect up to a system that's, 3 miles offshore and I can't put a person on it, I want to be able to look at every single attribute and every single data point up there to analyze my problem. He said, the gaming technology is real. It's three-dimensional rendering at its finest to be able to look at this stuff. But I have to argue that the most important thing that we need to do, and it's really leveraging, you got a multitude of connected devices out there, and as Anna started to talk about, we need to be able to aggregate a lot of that data and do analytics and turn it into information, because that's what, really makes sense. You can't just take, now we've got tons and tons more data than we ever were able to have 20 years ago. You don't want that much data. You want information. And I think that's probably the biggest key, analyzing that data. It's kind of like on your car. I was talking to somebody that's doing automotive right now, actually in the car, And then we've talked about the infotainment API, we've talked about all the different sensors, okay? Do I really want, yeah, I want to know that my one tire is down on pressure. But what I really want to know is this going to cause me a problem rather than me just kind of pulling the data, push something to me before it becomes a problem. And that's information.
Do you have a question, miss? Completely agree. Let me add a couple things, just because I'm the father of a couple millennials. I think everybody that builds a user interface from here forward ought to sit and watch their kids and how they game and how they drive the internet violently when they're not gaming. I mean, I used to think I was impatient, as a coder, I'd pound my way through screens. I'd watch my daughter. She makes me look like a novice, and she's 23.
You and me both.
Gentlemen, I'd like to thank you all for your participation in this panel and everybody in the room. I have two logistical things I'd like to ask you to do. One would be to rate the session with the ARC app, and the other one is a reminder from our fearless leader, Andy Chadda. You can either board a bus at 6:30 over by the gift shop, which will shuttle you over to SeaWorld, or you can walk over there. Take your options on that. And general advice, dress warm. I thought Florida would be warm, but no, it's cold and windy here.
There was a recent update that said the buses will start to leave at 5:45.
Even better, thank you.
That's that phone app, we need to get hooked in here to this.
I need to pay attention to. With that, thank you everyone. Thank you guys.